Hello guys, my name is Bongi. Okay, so today I want to teach you some few things. Okay, but we're gonna cover some few topics. Let's talk about the capacitors. Okay, let's talk about the ceramic capacitors and titanium capacitors. Okay, so what is this? Okay, this is a diode. Oh, okay. Anyway, I think I'm gonna cover some few topics anyway. Okay, so here I have the bad guys. These are all the bad guys. Okay, and here these are all the good guys. All right, I'm sure you are shocked. So let's start with the capacitors. Let's talk about the capacitors. Okay, anyway, let me just put it like this. Let's talk about the capacitors. Okay, so the capacitors, these are the capacitors. I'm gonna put some few under the microscope as well. Let me see my microscope. Where is my microscope? Let me see my microscope. Okay, yeah, I'm gonna put some few under the microscope. Okay, okay. For now, let's talk about the ceramic capacitors. This is the big one. Let me push away all the other ones. Let's talk about the capacitors. Okay. Anyway, this is a capacitor. Okay, this is a ceramic capacitor. They are always brown like this. Okay, so we have different types of capacitors. So I'm gonna cover two types today. We have the ceramic capacitors, and we have the titanium capacitors, and we have the electrolytic capacitors. Okay, hope you understand. Okay, let me write down. Number one, you're gonna start with ceramic capacitors. Okay, so this is a sign. Let's say you have the 19 volts here. Okay, so along the 19 volts, and then here you have the negative. Oh, anyway, I think I better use black and red. Let me check my markers. Let's hope my red is working, so that you will understand. Okay, yeah, good. This is my red. Forget about this. Okay, no. Let's make it this right. This is my red. This is my 19 volts. Okay, obviously it's positive. All right, and then This is my black. I don't have a black marker, so I'll use this color. This is negative. This is negative, but we call it, but here in our case it's ground because we're dealing with laptops. We're dealing with a DC. It's ground. Okay, and this is positive. All right, so you will have the ceramic capacitors here along the way, and this is the sign for ceramic capacitors. There is a space in between, meaning negative, meaning ground and positive, they don't touch. Okay, to prove that, let's go to our, let's check our multimeter. This is our multimeter. Let's take one capacitor. This is a ceramic capacitor. You put your multimeter to continuity mode. Okay, make sure it's 00. Okay, 00, as you can see. This is how you check and measure a broken ceramic capacitors. You touch both ends. As you can see, we're getting nothing. There's no continuity, meaning power doesn't jump from this side to the other side. As you can see here, negative and positive are touching, but in this case there's no continuity. Of course, there's no continuity, as you can see as well. There is a space in between. So we use ceramic capacitors to smooth the electricity, to remove all those unnecessary noise on the electricity, to remove all those unnecessary frequencies. We use them to clean or to purify or to rectify our electricity. Okay, so this is how you check and it is how you measure the ceramic capacitor. As you can see, there's no continuity at all. All right, let's switch to our microscope so that you will see clearly. This is a capacitor. This is exactly what I was doing. I was touching like this, and there was no continuity. So when you touch like this, there's a continuity. You can hear the sound, but when I do this, there's no continuity because there's a space in between. Okay, only the AC will travel here from the DC, meaning we're trying to remove the AC from the DC. That's exactly what I was saying. We're trying to purify, to clean the electricity. That's why you will have the thing. So in most cases, when the laptop is dead, the 19 volts, meaning the ceramic capacitors. Okay, let me just draw a few of them. And let me just draw the last one here. Okay, none of them they are touching. Okay, so if one, let's say this one decides to die and then it gets shorted, meaning now it acts as a wire. It allows power to jump from positive to ground, meaning now the power is jumping using this capacitor. So in that case, let's check the bad guys. Remember, I have the good guys and the bad guys. So in that case, you will experience something like this. This is a capacitor. Okay, a broken capacitor. It's not broken as such, but it's shorted, it's dead. So when you measure it with a thing, see, it's shorted. Okay, let me take it under the microscope so that you will see clearly. Remove the good guy. Let's go back to our microscope. Let's check it, let's measure it. you can see we are getting a continuity from one side to the other side. This capacitor is dead right anyway. Sometimes you won't see them, but in this, I think this one you can see it. I think the other side, see what's bent. So in most cases they will be like this, clean, but underneath they will be bent. But sometimes they will have a track. Hope you can see this is broken. So let me clarify something. Okay, let's go back to our diagram. So if one capacitor here, as I was saying, if this guy is shorted, all of them, they will behave as if they are shorted. If you, all of us, if you check this one from this point to this point using a multimeter, obviously there will be a continuity mode. Even this one, a working one, when you check it from this side to this other side on the board, it will be showing you a continuity as if it's dead. But when you remove it, there will be no continuity. But when you check it on the board, it will act as if there is a continuity. So that's why it's so hard to detect which one is shorted, because there will be like maybe 10 of them on that same power rail. Okay, there will be like a bunch of them. Okay, so now you won't know which one is shorted. Okay, you won't know which one is shorted, and you won't see it easily. Let me just draw another one here. There will be, you won't see it easily. So this whole power rail will be shorted to ground. When you check here on the positive, it will be beeping. When you check on the other side, it will be beeping. But now, just because of this one capacitor. Okay, so what these other technicians are doing, I was so shocked as well. They remove all these capacitors, all of them. Even if they are 20, they'll remove all the 20 capacitors, trying to find out which one actually it's usually broken. Imagine removing this one, removing this one, removing this one, trying to find that one dead capacitor. Okay, they will remove the whole pack trying to find this one capacitor, and they'll be checking them one by one from out of the board, because if you measure them here, they'll be all shorted. So what these guys are doing, they check one by one, from outside the motherboard, and that thing is so fucking dumb. Okay, it's so dumb. Let me just be honest, it's so dumb. Okay, so what you do, you take your DC power supply. Okay, you connect your ground to ground, and then you connect your positive to positive. You inject that specific voltage. Here we know that we were dealing with 19 volts, so you will inject the 19 volts. So what will happen, and then you limit your power supply a little bit. You limit your current a little bit, maybe to a range of 2 amps. Don't put the full range, because it will burn. This section will just burn straightforward. So that's why I'm saying limit your power supply, your current a little bit, then search for which capacitor is getting hot. You search for which capacitor is getting hot, you see, and then eventually this guy will get hot without removing these capacitors, maybe hundreds of them. You just search with your hands, search all over the board, okay, for which one it's getting hot. Eventually that shorted capacitor, it will get hot. If there's nothing getting hot, you increase your limit. You allow more current to flow on this shorted capacitor, and then by doing so, this capacitor will get extremely hot. Okay, let's do an example. Okay, I'm gonna take a dead motherboard. I'm gonna take any dead motherboard. Let me go around. Okay. Yeah, this is a dead motherboard. This is a dead motherboard. You can see, guys, you can see this is a dead motherboard. This is a dead motherboard. Okay, so what I'm gonna do here, I want to show you this thing. Okay, let me push this code, guys, aside. Let me put this. I want to show you under the microscope. Hope you will see what I'm talking about. Okay. This is just a board. I just picked up the board randomly. I know it's dirty, but I think those capacitors, they are not broken, they are working. Let's see if there's a short or not. See, there's no, okay, yeah, there's no short. They are not shorted. All of them, they are not shorted. They are not shorted. Let me switch again to my front cam so that you will see. I was checking these capacitors and they are not shorted. This one by one. Okay, let me reverse. See, I'm getting a value of 1 point something, 1 point something. Okay, okay, so they are not shorted. As you can see, they are not shorted, although they look dirty, but they are not shorted. So let's do an experimentally. Okay, let's go back to our microscope. Okay, so that these guys, all of them, they are working, right? So now I'm gonna remove one of them. Let's remove this one, the black one, because this one looks more ugly. Let's remove this one and replace it with a broken, and replace it with a shorted capacitors. You'll see that once I replace this working guy with a non-working capacitor, all of them, they will be shorted. All of them, they will be shorted. All of them will be shorted. Let's do an experimental. I've never done this before myself, but I know. Let's just go ahead. Let's remove one of them. Okay. Okay. Okay, we have this one out, the working capacitor. Let's replace it with a broken capacitor. I'm gonna put a broken capacitor there. Okay, first let me check the capacitor I have here if it's really broken. But I don't wanna okay, yeah. Oh yeah, it's broken. Let's replace it with a broken capacitor. I do have a broken capacitor here with me. Okay, nice. Done. It's clean as well. This is just dirty, so in a way you won't notice anything. It's just clean, it's just dirty. Let's just wipe them all. This is a very good experiment. It's gonna help a lot of people. Okay, so let's just clean the whole thing now. I know this whole pot is dirty, but this is just a donor pot anyway. So now you can't even see which capacitor here I replaced, okay, except that you can see that it's a little bit, you know, it's not exactly on the line, but yeah, you can't tell. Now let's check again using the multimeter. Let's check. Okay, I think, let me just take it here and switch back here. Remember this capacitors, and this is my my multimeter here. It's on the continuity mode. Let's check. See, we're getting a short. Getting a short. Okay. Two of them are shorted. See. Okay, let me explain this under the microscope. I know you will understand exactly as I predicted. Okay, so yeah, here's the case. This one is beeping, but before it was okay, and this one obviously the bed capacitor is beeping. But this one and then this, the last one, that they are not beeping, okay? Meaning what's wrong, see? But this one is beeping, as you can hear, shorted, and this one obviously is shorted. And this one is the cause, right? That's why even this one is beeping, because this is the cause. But this one, you won't get any beep sound. I'll explain why you won't get any beep sound from this one and from this one. Can anyone guess why? It's because these two guys, this one and then this one, they are not connected on the same power rail. Okay, what do I mean by that? I mean those two capacitors, meaning in my case I was having something like this. Having something like this.
Okay.
Oh, brother.
Let's see alone.
Yeah. So,
okay. I wanna check something.
Okay. Then. Okay. Sorry about that. So in my case, I was having something like this. Okay. That was my friend Walker. So I was having something like this. This was drowned in my case. Okay, meaning these two capacitors, they were on the same power rail, and then this one I replaced it with a shorted capacitor. Okay, meaning it was taking ground and positive together. Those other two I removed from both sides. They are not connected. They are not connected. They're not connected with these ones here.
I wanna use this one. Is a VGA cable can pass.
Okay, sorry about that, guys. My friend again. So I hope you understand the whole thing. And then again, let's go back to our microscope. So you see now why this capacitor is also shorted, because this one is shorted. Imagine if all of these they were connected into one power rail, and then I placed it with a broken capacitor, and now they are all shorted. You can't remove them one by one trying to find which one is shorted. You just do as I told you. You inject the 19 volts here, and then you connect your ground obvious here. Then a broken capacitor, this guy, it will get extremely hot, and then you remove it, and then you replace it with another one, then your problem is solved. Okay, so this is how capacitors are supposed to be. Anyway, I'm done with this short video. I hope you learned something. See you next time, guys. Next time I'll be talking about the thing about the resistors, but again I think I've covered the best thing about the capacitors. I hope you learn something about the capacitors. So what I told you is clear, and it is as it is anyway, guys. So capacitors, we use them to smooth the electricity. We use them for coupling, decoupling. We use them for those things anyway. So this is how you detect a shorted or a bad capacitor. Sometimes they will burn as well, but in most cases you won't see them. So they will be just normally. Just look at this guy. Can you, like seriously, can you tell which guy is dead here? You can't. You can't. There's no sign, there's nothing. You can't. So anyway, this is how it is, guys. These are capacitors, and they are called ceramic capacitors. Okay, and we have the titanium capacitors. We have electrolytic capacitors. Next time when I come back, I'll be talking about the electrolytic capacitors and explain the whole thing, why we use them and then when we use them. Anyway, I hope you learned. Please subscribe and share my videos. Let's help the society. Let's teach more people more and more. Thank you so much, guys. I will see you next time, and I promise I will post more and more videos for you to learn.